with a number of these chain rule derivative problems, after we do the chain rule, we wind up with these relatively complex looking answers, which have negative exponents, and they just look kind of unmanageable. And it's a nice thing to be able to simplify it into something like that, particularly to get rid of the negative exponents. Now, I just want to tell you from my standpoint, this top part here is the most important to get the calculus right. But it would be a good idea to go over a little bit of the algebra that would let us simplify it to something like that. So, you know, I've rewritten the unsimplified version of the derivative. And the very first thing I want to do to simplify things is really to look at my big numbers, my whole numbers. So I have 3 and a negative 2 and another 3, and that I know is going to give me negative 18. And I can put that right in the front and then rewrite everything else. And that's what it looks like. So I've simplified it a little bit. I still have these negative exponents. And I see that I have this 3x plus 5 binomial here and here. And I'm wondering if there's a way that I can additionally simplify this. Well, this 3x plus 5 right here is part of a larger binomial that is being squared. So I think, I mean, again, you know, I'm just trying things. So I would go negative 18 times, and I'm going to square out this larger binomial right here. So that would look like 3x plus 5 to the negative 4th plus 2 3x plus 5 to the negative 2 plus 1. Let's put all that in parentheses. And that is times this 3x plus 5 to the negative 3. And what I did here was I saw this binomial, which is of the form a plus b squared, so a plus b squared, and I know that is equal to a squared plus 2ab plus b squared. So this is my a squared, 3x plus 5 to the negative 2 squared. This is my 2a, which is 3x plus 5 to the negative 2b, 1. And then this is 1 squared. So I think I have that correct. And then I just multiplied it again by the 3x plus 5 to the negative 3. So I'm looking at it a little bit more, and I think what I want to do is I want to take this 3x plus 5 to the negative 3 and distribute it to each of these three terms. Again, it's the same 3x plus 5, and I want to see if I can do something with it. So I would have negative 18 times, well, 3x plus 5 to the negative 3 times 3x plus 5 to the negative 4 will give me 3x plus 5 to the negative 7, adding the exponents, plus 2, and 3x plus 5 to the negative 3 times 3x plus 5 to the negative 2 would give me 3x plus 5 to the negative 5. And then I'd have plus 3x plus 5 to the negative 3. And all that was times 18. So now here is the kind of new little trick that will help you with your negative exponents when you're simplifying. I want to look and see if I have the same term, if I have the same negative exponent term, like 3x plus 5, in each of my terms here, which I do, I want to factor out the one that is the smallest, so the -7. So that would give me, and you'll have to kind of maybe go over this another time or two, but it would give me -18 times 3x plus 5 to the -7. And now that is going to be times 1, because -7, that should be a 7. Because if I multiply this 3x plus 5 to the -7 times 1, I get this 3x plus 5. Plus 2 times 3x plus 5 squared, because to the -7 times the squared, add the exponents, it gives me to the -5, plus 3x plus 5 to the 4th, because 3x plus 5 to the -7 times 3x plus 5 to the 4th, add the exponents, I get -3. So now I only have one binomial with a negative exponent, and so I'm going to rewrite this as -18 times 1 plus 2 3x plus 5 squared plus 3x plus 5 to the 4th, and that is all divided by 3x plus 5 to the 7th. And if I kind of look up at my answer up there, way up at the top, my simplified thing, you can see that I wanted that as a denominator. And when you're doing these problems, it's not a bad idea to look at what is the simplified answer and kind of work towards it. See if you can make the changes necessary to go from here down to there. Yeah, you might not have thought of it, but if you do it a number of times, it'll begin to be kind of part of your being. And you're going to see, wait a minute, because my denominator, my numerator here is this, and then that really, I have to say, doesn't look much like what I have there right yet, except I can see something in the numerator, which you can see too. But I know that a squared, no. Sorry, don't do that. I know, and we just did this a minute ago, a plus b squared is equal to a squared plus 2ab plus b squared. Well, look what I have up here. This right here is 1 squared, and this right here is 3x plus 5 squared. So really what I have in my numerator is I have 1 plus 3x plus 5 squared squared. Now pause the video for a second, and you'll be able to see how that is how this right here is a quadratic expression of the same form as this right here. And again, after a little bit of experience, you will recognize it, and you'll recognize this 2 and all the plus signs as being kind of a giveaway. So now I have -18 times 1 plus 3x plus 5 squared, and that is divided by 3x plus 5 to the 7th. And you'll notice if I just rewrite that as -18 3x plus 5 squared plus 1, just using the commutative property of addition, squared, divided by 3x plus 5 to the 7th, I have gotten to the exact same answer that they got to simplify. So a little bit of algebra. Again, not worth a lot of points in my book because you know, I'm really more interested in the calculus, but I think it's really a good skill to have, and as you go on in math, it'll become more and more important.